Okay, I've started my video recording. I'm going to eat a sandwich and talk about atoms. What if you went to SM? Who teaches over there? Lambert?
I don't know, but female.
Yeah, they're all females over there. That doesn't help.
Her curve, an A minus is a 72.5%.
Wait, whoa, what class?
AP Chem.
Oh, 72?
72.5%.
Oh yeah, I would have maybe had, I'm not sure. But
Excuse me for having high standards.
okay.
Okay, like the first topic is supposed to be moles in Unit 1.
I have a fork and a mouse.
I have a red pen.
Do I need to describe molar mass?
No.
Actually, no, because I've never seen a question where they ask you to actually calculate the molar mass. It's always given, or it's an element.
I had a question like that today on the science section of this stuff.
A stoic question?
Calculate the molar mass.
Oh, well, okay. Yeah, that's a different test, though. That's not the AP test.
I'm not.
So, what's next after that? Mass spectroscopy? We'll talk about that.
How are you guys already done?
I put blue in my house and that shoe or that
So, they like to give you graphs like this, where it's mass, like atomic mass in AMU, and then this is like relative abundance, like what percentage of that element is made of atoms of that mass. And, you know, they'll look like, I'm going to make one up. So maybe this is like 21, 22, 23, 25. Meaning this is some element, and these are different isotopes of the element. And they like to ask, what element is this? That's a question they'll ask you. So the idea here is to sort of eyeball from the graphs, like, what's the average atomic mass if you took a weighted average of all the isotopes in nature for that element? Well, 23 is the most common. There's a few that are heavier than that, but there's more that are lighter than that. I would say from this graph I just made up, it's like somewhere between 22 to 23, some decimal in there. And so if you found an element where the number on the bottom of the table was in that range, that would probably be this element, right? Yeah?
Do we get a periodic table?
You do get a periodic table, yes.
Okay.
It's in the packet. It's in the test packet. It doesn't have the element names on it, though.
Wait, so it's just...
Actually,
Just the symbols and the weights
what calculator
and the
do you
atomic
have?
numbers.
Okay.
Mason, remember.
Oh, the calculator.
Oh, yeah, you can use one of your calculator. No one's going to stop you from doing that.
Hey, calculators like that are basic.
That's
Yeah,
pretty
I
much
have no idea.
that topic.
I'd get more if I could.
Me.
You get more?
Yeah.
Dual calculator.
I try calculators. I already have 3.
Oh my god.
You have not seen them. What do you mean those have?
What do you need 3 calculators for?
In case one dies.
All right, percent by mass. Let's say you have a compound. What's a compound I could give you? How about sodium nitrate? Why? It's fine. So you would need to figure out what percent, say you have some mass. What's the percent by mass of I don't know, how about sodium? Percent sodium by mass. Unless they say otherwise, they mean percent composition by mass, not by volume or whatever. That's easy. Okay, so you can find the molar mass of sodium divided by the molar mass of the whole compound. Right? Like, because molar mass is also the mass of a particle. in AMU. So how many AMUs out of this formula unit are made of sodium compared to the total mass? That's the percent by mass. It's like calculate a percent from a total. Okay. The flip side of this is they will give you the percents by mass and say, what's the formula? So let me maybe do an example of that. So working the other way, say you have something that is 40% carbon by mass, 6.70% hydrogen by mass, and 53.3% oxygen by mass. They might ask you, what's the formula, what's the empirical formula of that, right? Some compound, C something, H something, O something. What are X, Y, and Z? The trick with those kind of problems is to assume you have 100 grams of the compound.
Because then you take them from the percentage.
Because a percent means per 100, right? So if it's 40%, that means you would have 40 grams of carbon. You could convert that to moles of carbon using the molar mass, right? Like 40 grams of carbon times grams have to cancel. You need moles. 1 mole is 12.01 grams from the periodic table. Get your number of moles. Same thing here. So, assume you have 100 grams, so you'd have 6.7 grams of hydrogen. Convert that to a number of moles of hydrogen. 53.3 grams of oxygen. Convert everything to moles. Then you're counting particles, and you can figure out what's the ratio of how many particles of each element are in your compound. All right. If you did that, let me just tell you what the numbers would be.
For like free response, would they ever just ask you like one of these questions?
Huh?
Or would they ever ask you one of these certain questions in free response? Or would that mostly be like a...
They could, yeah.
Do like the questions normally incorporate like elements of like just a ton of different units into one question, or is it only like kind of like when you get a unit 1 question, or when you have like a question from unit 9 that is built off of like the question from like unit 7?
A lot of times it's multiple units in one question, especially for the long questions that are like part A through part G, that you want to give yourself like 20 minutes to solve. They might ask you this, and then they might say, okay, now here's a reaction equation with that compound. Tell me about the delta H stuff and something else. They like to mix it all up so that they have enough questions to ask. It is 60 multiple choice. You get 90 minutes to do the 60 multiple choice. And there are 7 free response questions.
7?
4 of them are the short ones that are like part A, B, C, D. And then 3 of them are the long ones that are like A through G. A good rule of thumb, if you have a watch, is for the short questions, try to do them in 9 minutes. For the long questions, try to do them in 20 minutes. You get an hour and 45 minutes total for all the free response. And then you just get the whole packet. You can answer them in any order you want.
This should just give you infinite time.
Where's the test room?
Like dehydrated.
It is ice.
Room 207?
That sounds right. I put it in an email last
Also,
week.
where's the alumni room? Because that's where
Right over there by the sheet music on the wall.
Oh, okay.
It literally says alumni.
It's under the sign that says alumni room. Yeah. Yes.
Between
Interesting time to raise your hand while your mouth is full. Go ahead. We'll wait. That's all right.
between that time, you get a break in between, or do you not get a break?
Yeah.
Because like
10
when I
minutes.
have time, per se, to charge my calculator.
Charge it prior.
Charge your calculator?
How does your calculator?
My calculator used to take triple A's.
Mine lasted like months.
Yeah, and yet you have 3 and
You guys
one
are
dice.
charging your calculators?
Yeah.
Yeah, I don't get that. That's weird.
You're supposed to do that? Well, no.
I never have heard of that.
Advanced calculators out.
Yeah, you're not
Our
solely
calculators
powered.
have periodic table color.
I have never once in my life charged my calculator.
Yeah, because you have probably
The one that has
you
the
have
battery.
like you have a like,
Okay, anyway, hello, children, let us finish this example.
Okay.
If you use those molar masses and you converted those masses into moles, you would get these numbers.
1, 2.
So that's a 1 to 2 to 1 ratio, so your formula would be CH2O,
I know that.
right? That's the empirical formula.
Calculators. I almost put my
Okay. That might not be the actual formula of the compound, though.
Stop.
Because it could be C2H4O2
How do you know that?
or C3H6O3, and that would give you the same ratio.
But how?
To find out what the actual formula is, they have to tell you what the molar mass is
Of one of them?
of the whole formula of the compound.
Say if they don't, should we just always go with this pyramid?
If they don't, then they're only going to ask you what the empirical formula is. You can't know the actual molecular formula unless they tell you the molar mass.
Yeah.
And then it will be just some multiple of the molar mass of this, and you can figure that out.
Like an example, like how they would word the question of like.
I don't have one right in front of me right now. Not off the top of my head.
Solve voice.
Okay. Let's see. That's not too bad. They also like to add stuff about mixtures.
So wait,
Just
what do we
looking.
have to get past again?
a 3.
A 3 is passing, which is about 50% of the available
A 3 is
points.
between 4 and 2.
Oh, thank you.
Yeah. 4 is one too many. 2 is
So say if I get like a 1 on the free response, how many multiple choice?
If you get a 1, well,
That's how like so far my record has been.
the short answer are worth 4 points, and the long answer are worth 10 points.
Don't like that.
So your total on the free response is 46 points, and they scale it up to be out of 50 and weight it equally with the multiple choice. 10 of your multiple choice don't count, but they don't tell you which 10.
So you're saying that if we get every multiple choice question correct, and we get every free response question incorrect, we still pass?
You might. I don't know. They might. That might raise a red flag somewhere.
Every single multiple choice question incorrect.
You put.
It's
Okay.
every 3 response wrong.
Exactly.
They like to ask this kind of question.
Like no, but even just like putting in like 1.
I got a 1 out of 10. Okay.
Contaminants.
Talk about it.
So let's say this. A sample of sodium bromide NaBr is 22.34% sodium by mass.
So, okay,
That was just given. Okay, and they might ask you something like this. What if that sample was contaminated with, for example, sodium chloride? How would that affect this measurement? The percent by mass of sodium,
Back into the cup.
right?
It is
chlorine's molar mass is pretty light.
The percent of sodium would
I don't
go
like
up.
babies. This is baby.
Well,
Yeah, babies are not.
it depends.
No, it go down.
I
What-
am against babies.
Like, if this thing that it's contaminated with, whether the percent by mass of sodium is higher in this versus lower. If the percent by mass of sodium is higher in the contaminant, it's going to raise this value.
And if it's lower, lower.
Right.
And if it's the same, it'll stay the same.
So, but chlorine versus bromine, chlorine is lighter. It's higher up in the table.
Yeah.
So this is higher percent Na which means the percent Na in the sample would increase. It would be too high compared to a pure sample of NABR, right? And then on the flip side, if it was contaminated with, for example, sodium, what's below bromine? Iodine, sodium iodide, which that has a lower percent of by mass of sodium, then the percent of sodium would be lower in my sample. That's a common question you're likely to see somewhere in maybe the multiple choice. All right. Enough of that fun math stuff. Yeah. It's always fun to hit you with all that right at the beginning of the
Mr. Lowe's,
unit 1.
I want to have something make sense.
you want to see a fun proof for 1 equaling 2?
No, because you're going to divide by 0, and I know because I was also math nerd when I was a youngster, and I know all the tricks that all the teens do.
One using infinite series. Seen that one?
Oh, look, it's time to talk about electrons.
Yeah.
Why are you booing electrons? Yeah, that. 2s2, 2p6, 3s2.
3p6, 4s2, 3d10.
4, then it comes the 4
The
p's.
one to the F is the F is F14.
For different orbitals.
F is 14, yep.
Yeah, I remember.
This is in order of increasing
I
energy.
didn't know to memorize that.
You don't have to. You can use the,
No, but like I don't remember what F is.
Honestly,
Oh, F.
your easiest way to remember this is by looking at this, your periodic table, and just reading across. The first 2 columns are the S, S2. This chunk over here is P. This chunk in the middle is D. And then the lanthanides and actinides are F.
We don't talk about it.
So, except for the top row, which is S2 is over here. 2s2, 2p, there's 6 elements there. Every time you're adding one more electron until the 2p's are full. And then 3s, 3p6, 4s2, 3d10. You just have to remember that when you get to the D block, you have to subtract 1 from what the row number is. There is almost certainly going to be a free response where they ask you, write the electron configuration for this element or this ion.
It's on the periodic table if you press it. It's there.
Or if you have a fancy calculator, you can make your periodic table tell you the electron configuration. It has the noble gas abbreviated version. Yeah, it figures.
They'll think we're smarter.
That's, you have to know that.
I completely forgot about the noble gas abbreviation.
And do I want to do that? I don't think you're likely to see that, honestly. The arrow diagrams. The PES, the photoelectron spectroscopy graphs. They love those. So this is number of electrons, and this is usually binding energy. Or, in other words, ionization energy, like how much energy does it take to eject those electrons. So this comes from experiments where they shoot radiation at a sample of something, and they measure the energies that are absorbed and how much. And usually they'll give you graphs like this. And so each spike is the electrons in an orbital being ejected. So this would be the 1s electrons, and you know there's going to be 2 of them. This would be your 2s2, this would be your 2p6, and this would be your 3s, probably 1 if it's half the height of the other s orbitals, right? So they like to give you graphs like this for the electrons and say, what element is that? Or what ion?
Something.
Or what's the electron configuration that maps to this? One thing to be careful of is this energy axis sometimes is reversed. Sometimes the lower numbers are on the right and the higher are on the left.
Yeah, I saw that. That's what got me.
So check this axis. You know why? It's because, well, I'm going to speculate that it would be the wavelength of light, right? That's bombarding it. Higher wavelengths are actually lower energies, so that's why it would be inverted.
Is it sodium?
Yes, that would be sodium.
Yeah.
Nice, good job.
It's one of 11.
Okay. Oh, look, the one I just made up is exactly the one that Dingle put in his book. 7 minutes left. Okay, what else do I need to talk about? Or remember this trick? The diagonal rule for that.
Oh yeah.
2s2, 2p6,
the only way I remember
3s2, 3p6, 3d, 10. And you go this way, then this way, then this way, and write all the rows down until you run out. That's the diagonal rule. I love the diagonal rule.
Same.
Okay.
Hey, you took my phone.
PES, periodic trends.
False accusations.
Go back up
My
here.
phone anymore. It was right in front of me before.
Did you take my phone or why did you?
Because you're normally the one who takes my stuff. Did you take Micah's phone?
Per ionic trends.
I guess. We're still studying, right?
In a way.
Yeah.
Here's my periodic table. Here's some trends you have to know. Please stop fighting. Electronegativity.
I hate electronegativity.
Only because I wasn't there this day. It's the one thing I don't actually.
Electronegativity means how hard do those atoms pull electrons to themselves in bonds. It increases from left to right. And it decreases when you go down. So fluorine in the top right is the most electronegative because it's got a small atomic radius, and within its row it's got the most protons pulling electrons. It's all Coulomb's law is the explanation for everything that's in these trends. Yes?
Is helium the most electronegative, or is that just
No, because helium's a noble gas,
Oh, wait,
so
sorry.
it doesn't form
I
bonds.
meant hydrogen. But,
No, not hydrogen either.
okay.
Fluorine.
Going down with period and then going plus a column?
Periods are rows.
Period
This is
row.
called a group. The columns are called groups.
Why are all the letters
Stop.
Radius decreases as you go left to right within a row. Why?
That's how they set it up.
Because there's a greater attacking force.
Because there's more protons in the nucleus as you go left to right, which means there's a stronger Coulombic attraction for electrons, and so the ones on the outside of the atom are pulled
Because the
closer.
relativistic mass increasing.
And then radius increases going down a column because every time you go down, you're talking about an atom that has another energy level, another orbital for electrons to live in, and so you're adding shells to the onion of the atom as you go down.
So wait, it's more electronegative because it has more protons.
Right.
So why
More
would-
protons means it's going to pull harder on electrons.
Okay, well then why would fluorine be the highest?
Because fluorine has the most protons in its row, and within that column, it's the smallest. It has the smallest radius. So the electrons it needs to pull on in that bond are closer, and the distance has the biggest effect on the electric force strength.
Okay.
So it's the amount of protons in the nucleus, the nuclear charge, and the distance where the valence electrons are away from the nucleus. Those two are the factors you have to think about.
So the most electronegative would not be I don't know, zinc or something, even though it has more protons, it's just not as.
Its electrons are farther away, though.
It's electron.
And so that's a bigger effect. The distance is more important.
Okay, got it.
Oh, one other thing here, ions. Can I just draw on this? +1 ions, +2 ions, -1, -2,
Oh, God, right.
etc. Right? Those are your ion charges. This comes from the octet rule. Atoms want 8 valence electrons. And so that's why they form those ions with those different charges. Because a neutral atom of something in this column has 1 valence electron that it wants to get rid of. So it gets a +1 charge after it loses that electron. Stuff over here has 7 valence electrons. So adding 1 gives it 8, and that gives it a -1 charge. Okay? Metals lose valence electrons. Non-metals gain them. To form ions. And remember that if you just count the tall main group columns from left to right, that tells you how many valence electrons that element has in a neutral atom.
Can you move to the left real quick?
We have a video.
I think it's actually it. That's all I needed to hit for unit 1.
Okay, after AP stuff, we all need to actually find
Oh,
greater level outside school.
what was I going to say? Oh, I don't know if you got my email, but the library has review books that you can have now if you want. They are good multiple choice practice in there.
Outside school.
I'll send out another email, but I also found more review videos from AP Classroom that you can use.
We just gotta like.